Today we are going to discuss about power flow analysis. What are all different? We are going to the power flow solution, power flow analysis. Power flow analysis is also called as load flow analysis. It is also called as load flow analysis. This is the next topic in the power system analysis. Instead of telling analysis, we can even tell a load flow solution, power flow analysis, power flow solution. Instead of telling analysis, we can even tell analysis here means a power flow study or power flow solution. First of all, we need to know what is meant by a power flow equation. What is meant by a power flow equation? And we need to derive the power flow equation, static power flow equation. Let us consider this. This is I. Here we had a bus, and this is, let us consider the I. This is the ith bus, and the voltage across this bus is Vi. Then here it is connected to bus 1 with the voltage V1, and the current through this bus 1 is I1. And the impedance admittance is yi1. Since it is connected between ith bus and the first bus, yi1 is the impedance. Then we had one more thing, bus V2. Current across this bus is I2. And the admittance is yi2. Similarly, and so on, we had n number of buses. Finally, we had Vn, that is the nth bus with voltage Vn, and the current across the bus is In. And the admittance across the bus is Yin. And it is also connected to ground. This is ground. So here it is a 0 volts. And then current across this is I. Actually, we can tell it as II. And yi0. Now, if you apply KCL, Kirchhoff current law, what we will get? II is equal to, actually this is I not I, sorry. II is equal to sum of incoming currents is equal to outgoing current. So I1 plus I2 plus I3 plus and so on, IN plus I naught. I naught plus I1 plus I2 plus and so on plus IN. Now, what is I naught? I naught is actually Vi. Here it is Vi. No, Vi minus 0 into Yi 0, which is equal to Vi minus 0 into Yi 0. Similarly, what is I1? I1 is Vi minus V1 into Yi1. Vi minus V1 into Yi1. Similarly, I2 is Vi minus V2 into Yi2 and so on. Plus In can be written as Vi minus Vn Vi minus Vn into Yin. Now, if you take Vi common, what we will get? In this, I am taking Vi common. If I take Vi common, we will be getting Yi naught plus Yi1 plus Yi2 plus and so on Yin. Yi naught plus Yi1 plus and so on plus Yin. Similarly, what is the leftover thing is minus V1 Yi1. I am taking that minus common. I take that minus common. V1 Y1 Yi1 plus V2 Yi2 plus and so on plus Vn Yin. Now, if you see this, I can write this as Vi into, since it is a summation, I am writing it as summation I is equal to J is equal to 0 to N. 0 to N Yi0. You should see one thing here, very important thing is here Yi0, Yi1, Yi2 and so on, Yin are the admittances between ith bus and another bus. So if here we are using J as the another term, so J is varying from 0 to N. If J is equal to I, it will become Yii. Yii means admittance between ith bus and ith bus, which is not possible. Hence, we should write here J is not equal to I. j is not equal to I. Then minus this summation can be written as j is equals to 1 to n vj into yij. See here v1 yi1, v2 yi2. So summation j is equal to 1 to n vj yij. Now here also j is not equal to I again. J is not equal to I. What is this I? Now we had derived the power flow equation. We know what we know. Complex power, actually complex power SI is equal to VI into I. Normally complex power is equals to V into I conjugate. So complex power SI is equal to VI into II complex. From this we can find II is equal to SI conjugate divided by VI conjugate. Now we know what is meant by SI. Actually, S is equals to P plus JQ. We know that complex power S is equals to real power plus J into reactive power Q. So what will be S conjugate? S conjugate will be P minus JQ. P minus JQ. So I am substituting this S conjugate here to get II is equal to P minus JQ divided by VI conjugate. Now I am substituting this II in the previous equation. What is the previous? What we had in the previous? We got previous final equation as this is the previous final equation. This is the final equation which we had got. So if I substitute II there, what I will be getting? We will get PI minus JQI divided by VI conjugate actually when j is equals to 0 to n yij, we can neglect j is not equals to I. So it will become Vi into Okay, it's okay. J is not equal to I. Okay, we can write it. We know that we already know bus building algorithm, how to build a admittance bus. So we know that y, suppose example, y11 is equal to, how we will write y11? Y11 can be written as y10 plus y12 plus and so on y1n, if it is a n bus system. So similarly, if you observe here, summation j is equals to 0 to n, j not equals to I, yij can be written as yii. From this, you can understand why I had written like this, minus summation j is equals to 1 to n vj yij. This is one major formula. You can use this formula. Otherwise, you know what we know. Actually, this is actually why I say na or diagonal element. So this is self-admittance. This is actually self-admittance. What about off diagonal elements? We know off diagonal elements, how we will write. While forming a y bus, off diagonal elements y12 can be written as, which is equal to y21, which can be written as negative of the admittance between first bus and the second bus, or which is equal to negative of the admittance between 2 and 1. So when coming to self-admittances is nothing but diagonal elements. Self-admittance is like that is yi is the diagonal elements. Self-admittances, we will just add all the admittances connecting to the bus. Coming to mutual admittance, this is actually mutual admittance. That is off diagonal elements. Mutual admittance is equal to admittance, negative of the admittance between the buses it is connecting. That is mutual admittance of 1 and 2 is equals to negative of the admittance between 1 and 2. This is mutual admittance actually. So what I can write, I can take this minus minus yij, and I can write this as vi yii plus summation of j is equal to 1 to n vj into capital Yij. That is that small yij and negative together gives capital Yij. This is also Pi minus JQi divided by Vi conjugate. Now you can use this. When you are using this formula, you can directly take from the y bus. That is, suppose you had a y bus like this. This is one, this is second bus, and this is the third bus. And there is an admittance Y12 connected between 1 and 2. This is actually Y12. And you had an admittance of Y23 between these two. And you had an admittance of Y13 between these two. Now, when you are using this formula, you can directly use these things. But when you are using this formula, that is wait. When you want to use this formula, you should convert this into y bus. When you convert this into y bus, capital Y12, what it will become? Capital Y12 will be is equal to negative of this small capital Y12 and capital Y21 will be is equal to negative of small y12. So when you are using this formula, you should consider the y bus, this element and this element are y bus elements. You should consider only the y bus elements, these two. Anyhow, I remains the same here also. But this element alone should be taken as direct given one. This and this both are same. You should take this directly when you are using this formula. When you are using this formula in place of this Yij, you will be using this. So be careful while using it. Now this is the, what is this? This is the power flow equation. This is the power flow equation. This is the power flow equation. Now, if you observe this power flow equation, this is non-algebraic equation. Algebraic non-linear. Sorry, this is an algebraic non-linear equation. Now, the power flow equation obtained this power flow equation is a algebraic nonlinear equation. Algebraic nonlinear equation. Now, to solve a algebraic nonlinear equation, we know for solving the nonlinear equations, we had mathematical methods, numerical methods. Mathematical methods. Numerical Mathematical iterative methods, actually, we should say. Mathematical iterative methods. We know what are all the different iterative methods. Iterative methods. Now we will be repeating the solution till we get a assumed tolerance. Now we will see what are all the methods available for solving the power flow equation. For solving power flow equation, we had numerical, mathematical, iterative methods. What are all the different iterative, numerical, mathematical, iterative methods? We will see. First one is Gauss-Seidel power flow solution. Gauss-Seidel. Second method is Newton-Raphson method. And third one is fast decoupled method. You can see that these three are the numerical, mathematical, iterative methods which we are going to discuss. Gauss-Seidel, Newton-Raphson, and fast decoupled methods. Before going into Gauss-Seidel, Newton-Raphson, and fast decoupled methods, we should be knowing some basic things. That is, what are different types of buses available? Types of buses. We see what are all different types of buses. First one is PQ bus. PQ bus is also called as load bus. Then second type of bus is PV bus. This PV bus is also called as generator bus. Next bus is slack bus. Now, if you see how it is classified, this PQ bus, we had 4 parameters. P, Q, voltage, and delta. Delta is actually voltage angle. Normally, voltage is equal to modulus of V at an angle delta. So delta is voltage angle. If P is given, Q is given, and voltage and delta are unknown, then it is known as PQ bus. PV bus name itself we had P is given, Q is not given, voltage is given, and del is not given, then it is called as PV bus. Now, what is the slack bus? Slack bus, what is slack bus? In slack bus, P is not given, and the Q is also not given, voltage is given, and del is given. So we had three types of buses: slack bus, PV bus, and PQ bus. In PQ bus, P, Q are known and V, del are unknown. Whereas in PV bus, P, V are known and Q, del are unknown. In slack bus, V and del are known and P, Q are unknown. In next lecture, we will be seeing what is Gauss-Seidel power flow solution or power flow method. And then what is the need of slack bus and some basic, first of all, we will see some basic concepts regarding the power flow studies or power flow analysis or power flow solution. What is the purpose of power flow solution? And then what is the need of slack bus in a system? And then we will see into Gauss-Seidel power flow solution. With this, I conclude this lecture. Thank you, everyone.